Hey guys, and welcome to the last lesson in our Introduction to Pandas series. So far in this course, we learned about how to start using the Python data analysis library Pandas. We covered different topics including how to get data into and from Pandas data object, data cleaning and joining, data visualization, and many more topics. So in this final lesson, we will have a data project to allow you to practice the use of Pandas library in a real-life scenario. To learn more details about this task, let us click on lesson number 10, Pandas Analysis Project. So I'm sure you guys are aware about the huge impact of COVID-19 outbreak on our lives since the beginning of the pandemic in late 2019. I'm recording this video in January 2022 and we are still dealing with a lot of lockdowns and travel restrictions. Since the beginning of this outbreak, many datasets have emerged trying to show us the impact of this pandemic on every aspect of our life, like from the economy, social activities, working pattern, travel, and so on. In this project, we are collecting some free and publicly available datasets to put them together and try to understand the impact of COVID-19 outbreak on your country and community. So to do that, we will make use of the following two datasets. First is the Google Community Mobility Reports, which are the free datasets provided by Google to help us understand how people movement behavior have changed at different places, such as the workplace, outdoor parks, public transportation, and so on. The second dataset is the COVID-19 Confirmed Cases dataset provided by Our World in Data and contain a lot of frequently updated details like total and daily cases, vaccination rate, availability of intensive care unit, and so on. So let's try to collect these datasets and see what kind of insights we can find about the response and the impact of COVID outbreak in your local city, community, and country. As usual with any analysis project, we start the work by accessing the datasets. We will first get the Global Mobility Report dataset by downloading the CSV file from the website and saving it into our local computer. So we did that and saved the file in our local dataset folder. As you can see here, this is the same folder we used earlier in the course to save other datasets. So all we need now is to read this dataset as a Pandas data frame. Now for the second dataset of daily COVID cases, the file is actually updated daily and uploaded to a GitHub repo. So there's no need for us to download a local copy, as we can access the data directly from the GitHub repo. Okay, so we run this cell, and this may take a little time for the data to be downloaded completely. Alright. So it seems the data was downloaded correctly, but we have some warning about possible issues with the data type. This is not actually an error, but the COVID cases dataset is actually a very big file, and for some of the values may have some issues with the data type. So let us start to explore these data frames and see if we can discover anything useful. We start with the Mobility Report dataset. We use the info function to give us a nice summary about this dataset, and we show the top few records of the data frame using the head function. We learned about both of these functions in a previous lesson. So we see here that the Mobility Report data frame has more than 7 million entries and about 15 different columns. The dataset contains columns about the geographic locations, collection date, and multiple numerical values about the reported mobility activities. And this is how the datasets look like. We see some records about location like place ID and of course collection date values. So let us do the same process for the COVID cases dataset. Okay, so we see for this dataset we have about 130,000 entries as of now, and this number keeps growing every day. We also see columns about location, dates, total number of cases, and so many other useful information, like the number of deaths as a total and as the percentage to the population of the country. And we also have information about the availability of ICU units, hospitalization rate, test, and vaccination figures. So it's actually a very rich dataset, and this is how it's looked like. So in order to use these two datasets to try to understand the impact, let's pick up a location where we can see how the impact happened in a given area or a country. We will use the country of New Zealand to demonstrate this process. But for you guys, feel free to change that to your local country or a place you may be interested in. From examining the two datasets, we notice that they both have some sort of a date element. So in order to watch how the impact of the outbreak developed through time, we learned that one of the best things to do is to use the time series visualization. We also learned that in order for the time series visualization using Pandas library to work, it is a good practice to assign the date value as our index value. This will help the plot function to show the time or date column as the x-axis. So let us try to do that for both datasets. So in this code cell, we updated the default index value for both datasets to the date column using the setIndex function. Notice how we make use of the inPlace parameter within the setIndex function to make sure the changes are permanent. So we hit Ctrl Enter and see that the cell did run successfully. So that's all good. Let us now go ahead and try to visualize the impact of COVID outbreak in the country of New Zealand. So to do that, we will use the COVID cases dataset and we try to find whatever column in that dataset to use as a filter. Let's say we only want records from the country of New Zealand, and we are only interested in the new daily cases as we can see in this command. So we see for this query, what we did is we first identify the data frame name, which is the COVID cases, and then we applied the condition to limit us to a subset of the record to filter only the country of New Zealand. And from that subset, we added another filter to say that we only interested in the new COVID cases. Once we have that, then we apply the plot method that we learned about in the last lesson. Notice how we didn't specify the plot kind, so the function applied the default behavior and generated a line chart or what's called the time series chart. Also note the use of the figure size parameter to identify the figure size. So we see here from the visual representation the first initial spike in COVID cases in the early 2020. Then, for the most part of 2020 and 2021, there was almost very low number of cases until around August 2021, where we noticed there was a new outbreak or spike, and that spike continued to grow as we moved toward the end of that year. So you can easily now change the ISO code value for your home country or the country that you are interested in and watch how the outbreak timeline changed in that community. So that's what we see from the actual cases. Now, what do you think will be the impact of case number on daily life activities such as people movement and traffic behavior? That's what we can see from the mobility report dataset. So let us try to investigate that for the same country or area during the same time period we used above. And here we will need to add similar filters to limit the location and movement pattern we need. Okay, so in this code, what we did is we used the mobility report data frame to filter to a specific subset or a specific country. So here we limited our query to the country of New Zealand, and because for this country there are no sub-region values, so we added the condition for the sub-region value to be null. And from that dataset, we used two different columns. The first column is the workspace traffic percentage change, and the outdoor parks traffic percentage change. So these patterns represent how people movement behavior has changed from the usual pattern prior to the COVID-19 pandemic. So what we notice here is that at the beginning of the pandemic, during 2020, we see a big drop where the country moved into a major lockdown and most people had to stay and work from home. So we see that both workspace and outdoor park areas have lower than usual traffic pattern. And then as lockdown restrictions started to be lifted, people started to slowly go back to work from office again and also enjoy visiting outdoor parks. And for the majority of time in 2020 and most of 2021, movement patterns were very normal until we noticed that same big spike here in August 2021. And we see the same drop in people mobility again as people had to stay at home again. And as restrictions started to be lifted again, we see things go back to normal. We also notice there are some interesting spikes like here around the Christmas time. So I will leave this for you guys to try to guess and figure out what could be the cause for these spikes. Think about what would be some external event that will change people's movement behavior. So things like holidays and extreme weather events and so on. So you can clearly see this big spike around Christmas time where there is so much activity at parks and outdoor areas, but very little activities around workplace. So I will leave you guys to see what kind of other datasets you may need to import and add to your analysis to understand these spikes. So this was a small project that we needed to collect two datasets and try to filter and apply some conditions to analyze the behavior of COVID-19 pandemic on people movement and travel behavior. Obviously, there are so many other things you can do using the Pandas library, and we hope in this course we give you all the essential things to start using Pandas library in your work. For more information about any of the built-in methods and functions we learned in this course, you can see more details at the Pandas library official documentation page. Thanks a lot guys for watching.